Hello and welcome to Datacasts. In this video we are going to create a Hexbin map in R. And we're going to create this Hexbin map that you see on the screen right now. And what this shows is the proportion of te reo Māori speakers within each local board in Auckland. Now that statement needs a little bit of unpacking. So what you see here are hexagons. And each of the hexagons represents a local board area in Auckland. And a local board is essentially an administrative area within Auckland. And each of these hexagons is sort of roughly located where you would see it on an actual map. Some of these local boards are going to cover larger geographical areas. So the Franklin local board, for example, down here right at the bottom, that is a sort of a larger rural area. But we don't want to exaggerate those things. We just want to show everything equally in order to kind of clearly show on the map where are the higher proportion of te reo Māori speakers. And we can quite clearly see on the map here that they tend to be concentrated down here in the southern local boards. Okay, so that's a quick primer on what this map is. But how do we build this? Well, let's switch over to Posit Cloud. And the first thing we're going to need to do is load up a bunch of packages. The first one I'm going to load is called SF. And in creating this map, I got to use SF for the first time. I'd never actually used this before. And if you'd like to learn more about SF, it has a really good website that describes what it does. SF stands for Simple Features. And you can read more about Simple Features access on the Wikipedia page, which is also linked here. So lots of good material here where you can read more about what this does. But basically, it allows us to work with geospatial data. So that's SF. And then these other packages, if you've used R to any degree, you've probably heard of them. So we are also going to use the ggplot2 package in order to create our chart. And we're also going to use the dplyr package in order to do a little bit of data wrangling at the start. And as part of that data wrangling process, we're going to work with strings. So we need stringr. And then finally, we are going to use a package called RColorBrewer in order to create a color palette that we will use within the Hexbin map. Okay, so those are our packages. So I'm just going to hit Control, Shift and Enter on my keyboard to load up all of those packages. And then we need to get our data. So first of all, we need to get the geospatial data, and then we will overlay census data on that in order to create the final Hexbin map. So the geospatial data comes from data.gov.nz via StatsNZ, and I will link this in the description box down below so that you can access this data as well. And they actually give a really good description of the Hexbin map, and they describe it as a pseudo-geographic representation of New Zealand's territorial authority administrative areas that gives each area an equal visual weighting. So that's a really nice, concise summary. And they go on to say that this data set helps map users visualize data for areas irrespective of their geographic size. In traditional geographic maps, small areas can be overshadowed by larger areas, even if their values are equivalent. That's a really well-written summary of what this data is all about, why you might use a Hexbin map. And so what I did is I went ahead and I downloaded the shape file. And if I just come back to Posit Cloud, and then if I look here within my data folder, and then I click into shapefile, so this is what I downloaded, you can see that actually there's quite a few files in here that I ended up downloading. And when we say shapefile, it does kind of refer to lots of different files. So the file that we're going to start off by reading is the .shp file, so the file with the .shp extension, and that contains the geometry of each feature. So that really is a key file that we need. But when we read that in using SF, it will expect some other files as well, including this .shx file. And that file is a positional index of the feature geometry. And it's especially important for reading the shapefile efficiently, particularly when the shapefile contains a large number of features. So the index within the .shx file helps the software, in this case SF, quickly locate the geometries for specific features within the .shp file without needing to read through the entire .shp file. But there are some other files that are also necessary here, such as the .dbf file, and that contains attribute data for the features. And we also have a .prj file, and that contains information on projection and coordinate systems. And then we have this sort of optional CPG file, and that stands for code page, and it's used to specify the character encoding for the attribute table data contained within the .dbf file. And that's particularly useful when your data contains non-ASCII characters, and I think we'll find that ours probably does. Finally, we have a .pdf, we have a .txt and a .xml. I think these three are all variations on a theme. So if I open up the .txt file, you can see this is essentially metadata. So it's just giving us information about the data that we've downloaded, some information about the license and so on as well. Okay, so that's a quick run through of all of these different files that make up the shapefile. But the one that we're going to read, as I said, is the .shp. So I'm just going to click rename on that and copy the name of the file so that I don't have to type the whole thing out. I'm going to create an object called data, and I'm going to assign that to st_read, which comes from the SF package. And then I'm going to point that to data/shapefile/ and then I'm going to paste that in, and then I'm going to add the .shp extension at the end. And now if I just run that one line, you can see that now here in the environment I have my data object, and if I click that, this is what the data looks like. So it kind of looks like a normal data frame, and it's got this this column here that has the names of the territorial authorities, which is going to be useful. And then at the end, I have this geometry column, which is a little bit different to the type of thing I might see in a typical data frame. And this is where that kind of key geospatial data is located. So I've read in that file, but I don't need everything within that file. I only actually need the local boards within Auckland, and I'm going to exclude the Great Barrier local board because Great Barrier is an island which is located quite far away from the mainland in Auckland, and I've had some difficulty sort of positioning that the way that I like in the final output, so I'm just going to drop it for the time being. So if I click back into data again and look at that column talb 2013_1, and here are the names of the different territorial authorities. Now if I just interactively filter here and I look for local board, and you can see here it's highlighting all of the rows that I want here, and they all contain local board area at the end of that string. And you can see at the bottom here I've got Great Barrier, which I want to actually remove. Okay, so let's do that. So I'm going to create a new object called local_board, and we're going to pass in the data object that we just created, and then we're going to pipe that into a filter function from dplyr. And this is then where we're going to use stringr. So we're going to use str_detect, and we're going to target that tabl, or rather TALB, and you can see it pops up with some options here, and it's this top one that I want. RStudio is really helpful here because it's actually giving me a little snapshot of the data contained within that column, and I can see, yep, this is what I want. So I'm going to select that. And what am I looking for in that column? I'm looking for space local board area. That's what I'm targeting. Any rows within the data set where the talb 2013_1 column contains space local board area. But I also want to add another filter, and I want to say that if I target that column again, I want to say everything that does not include Great Barrier local board area. I want to remove that one. And then the last thing I'm going to do is I'm going to pass a mutate function, also from dplyr. What I want to do is I want to create a new column, just the one new column actually, so I'll bring that back up. And I'm going to call that column labels, which is going to be equal to str_remove from string r, because I want to take what is in that talb 2013_1, but I want to remove the string local board area, including the space, and just return the name of the local board without those additional words. So what I want to remove is space local board area. So now if I run this, and I get an error because I've made a silly mistake here. I've said this is the string that I want to remove, but I haven't actually told str_remove what the column is, which is going to be talb_1. So now if I run this again, and now I've got my local board object, and if I just take a look at this, you can see that we have far fewer rows from the data. We're just getting the local boards. We're not getting Great Barrier, and we also have this new labels column, where we only have the names of the local boards without local board area included as well. So that's really good. What I also want to do here is I want to find the center of each of the hexagons, because when I ultimately create my visual, I want to put I want to add labels to each of the hexagons, the labels that give us the names of the local boards. And I want to position those labels right in the middle of each of the hexagons. So I need to find the center. And it turns out that there's a function from the SF package called st_centroid that will give us this information. So I'm going to create a centroids object, and I'm going to call the st_centroid function, and I'm going to pass my local board object and specifically the geometry column that contains that geographical information. So we're going to call, we're going to basically modify our local board object. So we're going to pass the local board object again, but this is where we'll modify it. So we're going to call a mutate, and we're going to create a couple of new columns here. One will be called label_lon. And this will be equal to st_coordinates, because we're going to extract coordinates from our st_centroid, and we are going to pass centroids, that object that we just created, but we're going to grab the data in the first column from this. So if I just highlight this, and if I just hit Control and Enter to see what this is returning in the console, you can see it's given us an X and a Y. So the X will be the longitude and the Y will be the latitude. So we're going to need to subset this to say, grab the first column, and that'll give us the longitude. And if I just copy and paste this, and then we can make a few modifications. So then we can say label lat equals the second column. And now if I run this, and we take a look at our newly modified local board object, we see that we have these two new columns, and these give us the positions that we need in order to find the center of each of the hexagons, which is where we will ultimately place these labels. So we're pretty much done with preparing the geospatial data. So now we can move on to working with our census data. And I took this from the StatsNZ website, and again I'll put this link in the description, and I downloaded the data for Auckland, and that downloaded a lot of files. So if I come back here to Posit Cloud, and then I go into my Census 2018 folder, you can see there's a lot of CSVs in here, but actually there's only one that I want, which is this one here, the 2018 Census Place Summaries Ethnicity Table 5. I had to do a bit of trial and error to find what I needed from here. So again, I'm just going to click rename and just copy that so I don't have to write out the whole thing. I'm going to create an object called census_data, and here we're going to call the readr package. I'm assuming that you have readr installed as well as all of the other packages that we've called so far, and it's within readr that we have the read_csv function, and then we can point that to data /census _2018 / then we can paste in that file and then add .csv at the end. If I just run that just to make sure that's okay, And yep, sure enough, if I just highlight census data, hit Control Enter, and then down here in the console, we can then see that we have read in that CSV file. But as with the geospatial data, we don't need all of this. You can see that it has 47,220 rows. We certainly don't need all of that. We only need the Auckland local boards. Now, if I open this up interactively again, so I'm going to click the census data object, and then I'm going to click Filter. And then within the area description column, I'm going to type local board. And you can see this is actually very similar to the geospatial data. It has the name of the local board followed by local board area. So we can use exactly the same method here as we did with the geospatial data to filter this data set to only the rows of interest to us. Okay, so we've read this CSV file. We will pipe that into a filter, and then we will say again str detect from the stringr package, and this time we're going to pass the area description column, and we are looking for space local board area, and again as with before, we are saying that area underscore description should not be equal to Great Barrier local board area. And if I run this and then I click again into the census data object, we now have far fewer rows, 400 of them, and it looks like we've only got these local board areas, which is what we wanted. But we need to go further than this because we're interested in a particular slice of this data, which is the piece of this that concerns Te Reo Māori speakers. So if I just open this up again, census data, we can see that we have these two columns of interest here, languages spoken total responses code and languages spoken total responses description. And we're interested in Māori. And to make this easier, we will filter by the code for Māori, which is 02. So I'm going to come back here and I think I'll create a new object, which I will call Māori underscore speakers. And we will assign that to census underscore data. So we pass that object that we just created. And then we pass that into a filter. And here we say languages spoken total responses code. And that will be equals to 02, equal for equivalence, as opposed to 1 equal, which would be assignment, and 02 because we know that is the code for Māori. And then we're going to pipe this into a select. So let's just select the columns that we're interested in rather than bring everything through. So we will want area description, and we will want, let's pull through census, usually resident population count, which might be of interest, and then we also want languages spoken total responses percent. So the neat thing about this data set is that we don't need to calculate the percentage of Te Reo Māori speakers within each local board because that's already been calculated for us, and we can just pull that column through, which is great. The last thing we're going to do is we're going to call mutate. And I'm going to create a new column called labels. So just like with the geospatial data, we want to pass a strremove, and we're going to pass the area description column, and we're going to say that we want to remove space local board area. We just take that out. There's one other thing I want to do here. If I just call the census data object in the console, and if we look at the data types, so if we look at census data, usually resident population count, and the percentage, these are actually encoded as characters, which we don't want. We want them to be numeric, so we need to convert them. An easy way to do this is just say across columns 2 to 3, because remember we've only selected 3 columns, and the second and third columns that we've selected are the ones that really ought to be numeric. So across columns 2 to 3 as dot numeric. So that will convert columns 2 to 3 to numeric. Pretty neat. So if I run all of that, And then again, if I just highlight Māori speakers and hit Control and Enter to take a peek at that in the console, and we've only got the 3 columns now, and we can see that we have area description, and we have a cleaned up version over here with labels that are removed local board area, and we can see that these 2 columns are now double, so those are numeric types, which is great. Okay, we're nearly ready to build the chart. A couple more things. We actually need to bring these 2 data sets together. So we're going to create our plot data now. And for this, we're going to do a left join. And we're going to pass our local boards data set. Or I call it local board singular, but it is actually, technically it's plural. So I'm going to pass local boards. And here as well, I'm going to say boards. So local boards, and then we're going to join that with our Māori speakers dataset. And there's a common column between those 2, which is label, and we've formatted the label in both cases to just contain the name of the local board. So that'll join quite nicely in theory. Let's try. And you can see, yeah, it did join, and then it tells us down in the console, joining with by equals join by labels. So it's joining by the labels column. And then if I take a look at that plot data object, we can see that it is just a sort of a combination of these 2 data sets that we've created. On the left hand side we have the geospatial data, and then over here we have the census data, and then right at the end it popped this geometry column, which is a little bit different to all of the others. But this is really everything that we need to create the plot. But I loaded the RColorBrewer package for a reason, and that's because we want to create a color palette for our plot. So let's go ahead and do that now before we actually build the plot. So I'm going to call this object color underscore palette, and all we need to do here is call brewer.pal, and then the first thing we're going to do is we're going to say how many colors do we want in our palette. I'm going to go with 9. And the palette name is called blues, because I'm going to use different hues of blue. And that creates our color palette. So if I just run that line, and then we take a look at what is in this color palette object, you can see that it gives us this character vector with a range of different colors that we will use in the plot. Okay, let's get plotting. So we can call ggplot, and we can pass our plot underscore data object into that. And then we're going to call geom underscore sf from ggplot. So we don't actually need to pass any x or y coordinates here, but we do need to call aesthetics in order to say that we want to fill each of the hexagons. And the value that we're going to use for the fill will be languages underscore spoken underscore total underscore responses underscore %. So that will be used for the fill, and then we're also going to pass color. And the reason we're going to do this is because we want like a faint gray color, gray 30 in this case, and you can see that RStudio helpfully shows us what that looks like. And this gray will be a line that separates each of the hexagons, so it just looks a little bit better. To show you what this looks like, I'm going to run that code. So I'm just going to hit Control and Enter. And then over here on the right hand side, you can see that we've created our Hexbin map, a very basic version, and you can see that there's a bit of a kind of a grey line between things. This isn't a great color palette. There isn't really enough to distinguish these different blues, which is why we created that palette. And we'll come back to that. But the first thing I want to do is I actually want to add the labels onto the hexagon, so I know which hexagon represents which local board. So I'm going to extend this to pass geom underscore label. And within that, I'm going to pass aesthetics again, and I'm going to say x. So the x coordinate for the label will be label underscore lon, and the y coordinate for each label is going to be label underscore lat. And then the labels themselves, so label will come from the column which is called labels. And then finally I'm going to make the size of each label, so the size of the font here will be 2.75. I know that I want to use 2.75 really just through trial and error, because I tried out different sizes and that's the one that looked the best to me. So if I just run that, And now I look over here on the right hand side, I can see I do indeed have these labels, and they are positioned in the middle of the hexagons. And the sizing looks about right to me. Some of them all run slightly, like Devonport Takapuna here is a little bit longer, but it's not too bad. I'm pretty happy with that overall. Okay, so back to that color palette, because these colors don't look good. So in order to implement that, I'm going to pass scale underscore fill underscore gradient n. And you can see the little help file that pops up here tells me that gradient n creates a n color gradient. So it allows me to pass a certain number of colors within the palette that I'm passing to this. So all I need to do here is to say colors equals, and then I can pass my vector of color palette. So if I run this again, and now I look over here on the right hand side, you can see that this looks a lot better. I can much more easily see the higher proportion of Te Reo Māori speakers in these southern local boards, Manurewa, Papakura, Mangareo, Tahohu, and then fewer in the more northern local boards, which are much lighter colour, like Upper Harbour and has hibiscus and bays and so on. So I think this makes a lot more sense visually. The darker the colour, the higher proportion of Te Reo Māori speakers, and then the lighter colour, the lower the proportion. And this also means that that grey line that I added is kind of standing out a bit more. We're getting kind of more clearer separation between many of the hexagons, which is great. That's what I was going for. Okay, but we're not done yet. There's a lot of clutter in this chart. I've got this grey background. I've got the axes with the labels and everything. I don't particularly like all of this. I need to remove that clutter. The simplest way of doing this is just to pass theme underscore void. And now if I rerun this, and just by passing that one function, if you look here, it's just taken all of that clutter away and just stripped it right back to the really just essential things that I want, the essential elements. So that's a really quick and easy way of doing that. But that's a little bit too minimalist, because I do want I do want a title and a subtitle. And also, I'm not terribly happy with having the legend here on the right-hand side. I feel that can probably be moved down below. I think it would look a lot better down below. So let's do that. So let's prepare ourselves for this by modifying the theme, first of all, by calling theme. And I'm going to call plot.title.position, because I want to make sure that my title is kind of shifted across to the left. Because people in many countries, in Western countries, will read from left to right, and so the first place your eyes will probably go once you do a quick scan of the chart, which kind of does stand out, is you're going to read the title, you're going to read from left to right, so it makes sense to position it there to make it easy for the eyes. And the way we do this is we pass plot to plot.title.position, which is not, I don't find very intuitive, but that's what you need to do to make sure that it is shifted across to the left. The other thing we're going to do is we're going to pass plot.title, because we want to adjust the size of the font. So for that we need to call element underscore text here, and we're going to say size equals 16. So a bit like with the label sizes, there was a bit of trial and error I did before I landed on font size 16 for the title. And then finally, we wanted to move that legend, so we're going to do legend.position, and that is going to be equal to bottom, and that moves it down to the bottom. Let's just continue here now and add in the titles. So we're going to pass labs for labels, and so our title. So I'm going to say Te Reo Māori speakers are mostly concentrated in Tāmaki, and then here I'm going to add \n to add a new line, because I know from having written this title before that it is at this point that I need a new line so that it doesn't run over or off the right hand side. Tāmaki Makoro's southern local board areas. And if you're wondering what Tāmaki Makoro means, that is the Te Reo Māori kupu, or word for Auckland. Because we're talking about Te Reo Māori speakers, it makes sense to use the Te Reo Māori kupu there for Auckland. So this title, I think, kind of broadly describes what we're seeing. Te reo Māori speakers are mostly concentrated in Tāmaki i Makaurau's southern local board areas, and that is what we see here. I'm also going to add a subtitle. And subtitles, it's a good rule here is to think that of your title as really the attention grabber. That is really where you want to convey the key information to the reader of this chart. The sort of one takeaway. If they didn't even look at the chart, the title's going to give them the key takeaway. There's nothing particularly exciting that I want to say about this data. It is just an example for this tutorial. And we've sort of said it. We've said the main takeaway in the title, but the subtitle is kind of where we give kind of the more boring stuff. So, you know, if I was critical and I was like, well, where did this data come from and what does this data mean? Well, we can use the subtitle for that. So it is sort of there, but we're not making it the focus. We're just providing this information to people who may want it. So we're going to say share of usually resident population per local board area who can speak te reo Māori. And again, I know from having written this before that is where I need to insert the new line. According to the 2018 census. And to be really good here, we're also going to provide the source for the data. So I'm going to put in a couple of new lines first, and then I'm going to do data, and then I'm going to come to the page where I got that data from. I'm going to copy that URL, and then here in back in Posit Cloud, I'm just going to paste that in. Okay, we're nearly there. One final thing. If we look over here again at the chart, we can see that we have a title for the legend that is not very friendly. Languages _ spoken _ told, blah, blah, blah. That's not very friendly. So let's change that. So in order to change it, we can just do fill equals, and then I'm going to say percentage who speak te reo Māori. I think that's all the components we need for this chart. So if I just run that, and then we take a look over here on the right hand side, we've now got our title, our subtitle, we've got the source of the data, and we've shifted the legend down beneath, and we've changed the title of the legend as well. Which brings us back to where we started, and that is how you do a Hexbin map in R. And you can see that we prepared the data, both the geospatial data and the census data, and we prepared a color palette, and then we created the chart all within fewer than 60 lines of code. So not as complicated as you think, certainly not as complicated as I initially thought. I had a lot of fun building this. I hope you had fun following along and that you learned something today. All right, and that is it for now. So I look forward to seeing you in the next video. Bye for now.